me.
There's what is it? There's a 30-year-old female last night that won a medal.
I think certain events kind of lend themselves to, I mean, like marathon running. Generally, the marathoners tend to be slightly older than sprinters, because sprinters wear your body out. With a marathon, you just kind of get fitter as you get older. And to a point. To a point.
And then your VO2 max.
They start going apart. But, all right, you convinced me to try to start watching the damn thing. How we doing? Okay? Everybody got their dice and their coin? Good, we'll play with that later. How was this?
Pain in my
It was easy, but
One question.
I did want to have, I apologize for this. It's one of those things I haven't had the time to do this term, is to make videos to accompany all the projects. I've got one or two on the last project and I'm working my way backward, but since I started recording, you guys knew that I was recording video solutions for quizzes, right?
Yeah.
Okay, since I started doing that, that's cut into the time. I mean, basically I have a finite amount of time I can record videos for. And I just got negotiations meetings added every Friday from noon to 3, which I am so stoked about, so very, very excited about, which cuts out even more time. So I want to keep up with the quiz solutions because they're more frequent than the projects. And if I can, I'll try to get more quizzes up, more more video help up for the projects. I do know this one's more intense than the last one. But did you see the intersection? In other words, did you see what was in common between the last one and this one?
Yeah.
Good. One yes. A lot of people gave me like, no, I saw absolutely no connection whatsoever. So what's the big difference? Other than the fact that you didn't like this one very much. Pat, go.
More data. Like you're using more.
Yeah.
Twisting it a little bit.
It's more realistic because you're drawing more than one thing. I mean, this is the way studies are done. You never see a study done on one draw of a marble or one person. Did you get sick? You got sick. Oh, 100% of people are going to get sick then. I mean, you never see that. You see a percentage of a total drawn. That's the whole point. And the thing about it is this is why, it's amazing how much this idea of likelihood governs your life and multiple probabilities governs your life. I tried to use that RAID disk example to drive home that point of redundancy.
And that was the hardest part for me. The seeds and the
seeds made sense, and that's what's so amazing about the RAID disk problem. It was the seeds problem, but I don't think everybody makes that connection right away. Because you think about it, the seeds germinate 60% of the time, which means they don't germinate 40% of the time. The RAID disk is just a seed, but it germinates 97% of the time, and it fails to germinate 3% of the time. But that leap right there is the trick. I think that making that mental connection between the fact that it's just a seed. I mean, Bug's life there for a second. I am a seed. But it's what it is. I mean, it's just one more. It either fails or it doesn't. So you plant more of them to increase the likelihood that at least one is going to germinate. At least one is going to work. And that's what the whole point of that question was, to get down. What's the chance at least one works? And it ends up being almost 100%, right? Yeah. The chance that at least one works. The chance that at least one fails is pretty high, as you guys saw. It's like 1 in 6 that at least one fails. But the chance that at least one works is almost guaranteed with the more drives that you put on. Now, redundancy works all the time. I mean, we have 2 kidneys for a reason. Because if you don't, and one fails, you die immediately. But if you have a backup, put a battery in your alarm clock, if you still use an alarm clock, right? I have 2 red reflectors on my bike and my helmet, and I've got 2 headlights, and I have reflective clothing when I bike commute at 5 a.m. because the chance of somebody seeing at least one of those things goes up with every piece of bling I put on my bike. With every additional piece, reflective shoes, boom, check. Every reflective piece I put on, every blinking red thing, I make them blink instead of solid. Because it makes more sense to me. It's more, I mean, that's how I sense motion. I'm assuming other people do too. They see things in motion more than they see a solid red light. So, I mean, it's all redundancy. And I know that was a trick. That was tricky to make that catch between the seeds and the
the one question was like B, because I couldn't figure out, was it do that problem, like where you said, what does this mean?
Oh, good. We'll come back to that at the break. Yeah, that's,
all right.
And we'll come back to it today in class. Today is going to be the fusion of probability and statistics, the beginning of the end of the course. I mean, the next 4 weeks are all about fusing the statistics we've been doing with these probabilities that you've been cutting your teeth on in the projects. And we're
It's
all together.
that kind of gets me.
It could be, and I try not to be confusing with how I word things. I try to use similarities in how I word things.
I think you explain it, but I think
It's just getting used to that.
Right.
I 100% agree. I mean, think about how many of you got frustrated when I asked you to interpret a standard deviation. And I don't mean frustrated in like, oh, this sucks kind of way. It's like, I want to be able to do this. I know I can do this. It's the same thing, being able to make sure you understand what a probability means. Same exact thing, it's just getting used to that. And I think today is going to help us kind of really hammer that in. Cool? Your next project, not due for a couple weeks, is it's called super counting and simulations. So today, at many points today, we're going to use Excel to simulate probabilities that currently we can't replicate algebraically. We're going to work towards replicating some of them algebraically, but some of them, honestly, just can't be replicated algebraically. You can only get them via collecting data. So, and the beautiful part about this is it's part of me trying to make statistics relevant for the 21st century. The more statisticians I talk to that are working out in the world, the more I realize that they're running simulations on almost everything. On almost everything. When you look at hurricane tracking and weather tracking and things like that, stock market analysis, they're feeding seed data points in and letting simulations go and seeing where they go. I mean, flight trainers, for lords. Anybody fixed wing or helicopter in here? Probably not, I'm guessing, no. But I mean, that's a flight simulator. That's all they do. Let's see how they're doing, boom, clouds. Let's see how they're doing a hurricane. So they're doing a hurricane and a tornado and a snowstorm at the same time. You know, which isn't gonna happen. But the idea is you can simulate things very quickly and very accurately. And that generally saves you a lot of money and time. Or sometimes money is time, or time is money. So your next project deals partially with running Excel simulations that I put together for you. And part of it's just some theory behind some number theory, some being able to count up things. Some great questions came up with this, why are we doing the 1 minus for the at least problems? Right, that was a great question I heard from a number of students, either emailed or talked face to face, like, when I asked you, what's the chance that at least one hard drive works? What's the chance at least one hard drive works? Well, here you got 6 hard drives, right? Drive 1, drive 2, drive 3, drive 4, drive 5, drive 6. Okay? Give me one situation where at least one of them works. Either each drive is going to work or it's not going to work, right? So give me one situation. Sketch one out. Like you come into work one day, you're IT, you walk in and here's your drives, and suppose they have a red light if they're not working and a green light if they are. What's one thing that you could see on a day that shows at least one of the drives is working? What might you see?
One not working.
You might see not working, not working, not working, not working, but then green, green. Whew, we're good. Because at least one's working. 2 are working, that means at least one's working, yes? That's one possibility, correct? And the chance of that happening, per this project, will be 0.03 times 0.03 times 0.03 times 0.03 times 0.97 times 0.97, using the multiplication idea. But that's only one way for at least one drive to work, isn't it? Give me another situation where at least one drive is working.
It's like B1 is not working.
How about not working? Working?
Working, 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 working.
So everything's working except D2, I guess, yes? So that's 0.97 to the 5th times 0.03. That's more likely than having a bunch of them not working. Good, that's another way. Give me another way that at least one's working. Are you getting bored yet?
Yeah.
You should be getting bored, because this is a pain in the ass. These could all be broken, these could all be working. Somebody said half of them. Half of them working. Well, there's a lot of ways for that to happen too. You could have the first 3 working and the last 3 not working. You could have these 3 not working, these 3 working. Work, not, work, not, work, not. Not work, not work, not work. Work, work, not, work, not. I mean, you don't want to deal with that. You don't want to deal with that. I mean, think about it. It's ridiculous, right? Die, they could all be working. That also counts, doesn't it? If they're all working, that counts that at least one's working. You don't want to sit there and add up all of those individual probabilities. So what are you going to do? What's the one situation that's the opposite of at least one of them working? Carly.
All of them fail.
All of them fail. That's the only downside. If you want at least one to work, the only thing that's opposite of that is they're all failed. 3% times 3% times 3% times 3% times 3% times 3%, which goes off to 0 very quickly, doesn't it? Which means the opposite of that is very close to the 100. So your next project begins to walk you through the mathematics of how to collect all those other ones, should you ever need them. And I'm not saying you will. Generally, you don't need the other ways. But every once in a blue moon, you do have to keep track of orders of things. And that project kind of walks you through why you don't want to do that one that way. But sometimes you need to know, what's the chance that half of them fail? Well, then you have to actually go in and figure out how many ways can you have half of them fail. I mean, these are analytics for IT departments. So I know it's a headache. It could be, especially if you start like last night at like midnight. I hope nobody did that. Oh my God. Please don't do that. The next one probably will be lighter as far as mathematics. There wasn't much math in this, did you notice? was all multiplication and division and some subtraction, but it's not that the math is hard, it's that knowing what to do was tricky. You know, when to take one away, when to not, and things like that.
And what to pick.
Of course, exactly, and what not to pick, which is sometimes just as important. So the next one has even lighter mathematics than this because the heavy hitting mathematics in that one, which is the same mathematics you see here, will be wrapped up in the Excel spreadsheets. So you've suffered through this and you understand like the basic mathematics, and then we'll start hitting some in class and some in that out of class project.
That's 2 weeks, right?
Oh yeah, week 8, not next week, week after. I posted a bunch of quizzes for you for next week. I put 3 up. Some people were saying they're getting nervous because they think that there are not enough quizzes in right now. I've been watching the numbers, and you guys are doing really good about getting stuff in. You have that number 10 that's kind of hanging over your head. I've got an in-class quiz planned. I don't think we'll get to it today. We'll definitely get to it on Tuesday. And then I think I've got at least 2 more in-class quizzes planned for class. So you can bank on 3 of those. But there's 3 next week posted. One is on relative position, which we just finished, if you will, finished. It's the second one. You already had, some of you might have turned one in the day about relative position, the percent below, and things like that. One is on outliers. I was going to do it in class last time, but I've said, well, let's put it up for next week, so it's posted for you. And then one is on measures of center, which is a total throwback to like 3 weeks ago, but it was about the snowfall from last Saturday, because I just couldn't resist that. It was too much fun not to talk about that. So, and it brings up an interesting point. Carly was just talking to me about, you know, that last question on the project being such an interesting question because, you know, you can answer it almost both ways. Well, can you ever get the probability of having no seeds germinate to get to 0%? And the mathematics says no, you're never going to get to 0. You're always going to get closer and closer and closer, but you can't ever get to 0. But Carly says that's kind of a ridiculous answer because you can get as close as you want to 0, right? Suppose you want to get within 100th of 0%, or 1,000th of 0%, or 1,000,000th of 0%. You could eventually plant enough seeds to guarantee that. You're 100% correct in saying that. Mathematically, you can never get to 0, but statistically, you could argue this both ways. You can get as close as you want to 0. It's just like an Advil you took in 1994 is still in you. I mean, if you think about it, Advil, whatever that is, ibuprofen, is that correct? Yeah, right? Yeah. That has a half-life, which means after, like, say, 8 hours, half of it's gone. So you take 1,000 milligrams, 8 hours later it's down to 500, 8 hours later it's down to 250, 8 hours later it's down to 125, then 62 and a half, I want to call that 60 to make the math easier, then 30, then 15, then 7, then 3 and a half, call that 4, then 2, then 1, then a half, then a quarter, then an eighth, then a 16. You see, you keep losing half and half and half and half.
It never actually reaches 0.
It never actually reaches 0, but it reaches 0 enough for the sake of taking your next Advil. So that's what Carly was saying, and she's saying it correctly. So think about that. Every Advil you've ever taken is kind of partially in you. That's crazy to think about. But it doesn't really matter because it's in you so little that it's basically essentially 0. So you can kind of get your head wrapped around that a little bit. It's the idea if I drop this marker, it'll never hit the ground because it has to always travel half the remaining distance. And if I have to keep traveling half the remaining distance, I'm never going to get to the ground because I can't get to 0. But the paradox is that it does hit the ground eventually. That's kind of the parallel of that, Ariel. Thank you. So anyway, yes, you can answer that both ways. I was looking for no, it can't get to 0, because mathematically it can't. But you can argue it statistically if you wanted to. I'd totally love to read that. So either way. I think most of you probably said no, yes, I'm guessing. Yeah, that's what, I mean, that's the pure mathematical answer. It's the idea of an asymptote. It's the idea of an asymptote, yeah? I mean, the exponential curve, as it goes off, as it decays towards the x-axis, but never touches it. You can always zoom in, and there's always a distance. So I was looking for that. But Carly's saying that the distance is negligible. It's a good point. It's a good point. When you take math outside of the classroom, you have to address that, don't you? You have to talk about that, because eventually the tolerances are so small you can't measure them anymore. So, good. Thank you for that, sister. It's also a good definition of an outlier. I mentioned 2 in class last time. We kind of developed them together, actually. You know, if you have bell-shaped data outside of 2 standard deviations, if you have any data, you can do the box plots. Another definition of an outlier that's often used is anything that doesn't happen very often. So, something that happens, say, only 1% of the time. That's rare. 1%, 1 out of 100 happens. You can call that an outlier. So something that happens very, very rarely can be defined as an outlier. So if you plant enough seeds, eventually the chance of having none of them germinate is negligible because you say it's an outlier. You're not gonna, I mean, if you plant 1 seed and it doesn't germinate, you have no right to be pissed. Because that's going to happen 40% of the time. 40% is definitely not rare, right? That's not rare. That happens all the time. But if you plant 2 seeds, all of a sudden you're at 84%, which means you're at 16% non-germination. You're like, still 16% is 1 in 6. That's going to happen 1 in 6 summers. That's hardly rare, 1 in 6. So plant a 3rd seed. Or plant a whole row of them like we do, right? Plant a whole row of them. And the idea there is, if you've planted a whole row, now the chance of none of them germinating is essentially down below 1%. And now it's rare. Now it's unlikely that you won't get germination. So it's likely that you will get germination somewhere. Does that make sense?
And you're gonna have a lot of pumpkins.
You might. It depends. It depends on how kind of summer we get. Sometimes those things take so long to ripen that they get zapped in September. We always usually get good ones. At the first couple of years, we get those big Max ones, like you saw that picture with Max. We haven't had one that big since he was 2. Now we plant the big Max ones, they end up getting this big. Because they get zapped. They get zapped with some early frost, the leaves die off. We leave them on the vine, and we're always hopeful. We still carve them. They have tiny heads. So we're going to try again this year. I'm going to get them started inside in about a month. And just keep nurturing them inside. If I can keep the cats away from them. Freaking cats eat everything.
What?
Corn. Corn grows great here. You keep your cats out of it. All right. Doing okay? Yeah, feeling good? All right. Let's get into some other stuff. I want to feel like today is really a fusion. Today is not like that crappy music. It's a fusion of